Welcome students. Today we will talk about isometric projections. So let us start today's lecture. Now we know whenever we have to communicate the design of any object to the manufacturer, then we have to prepare engineering drawings. And on engineering drawings, we sketch different projections of an object. Like over here in this drawing, we have drawn three views of the object. We have drawn front view, top view and right hand side view of the object. Now these drawings will be clear to only that person who has the knowledge of orthographic projections. So in order to understand the geometry of this object, reader must have the knowledge of the fundamentals of orthographic projections. Only then he can get the geometry of the object. In order to make the geometry of the object more clear to the reader, we assist orthographic projections by one more drawing. We call that as isometric projection, or in layman language we can say 3D drawing of the object. A benefit of drawing isometric projection along with orthographic projection is that if reader get confused with any of these projections regarding the geometry of the object, then in that case he can refer isometric projections. So isometric projection will give the reader more understanding about the geometry of the object. So isometric projections are especially helpful for the objects having complex geometry. So these drawings act as auxiliary drawings to orthographic projections. So whenever we have to convey the design to the manufacturer, or whenever we have to prepare engineering drawing, so primary drawings will be orthographic projections only. But in order to assist those orthographic projections, we give one more drawing that is called as isometric projection. And we add these projections when we feel that the geometry of the object is complex and reader may get confused while reading the orthographic projections. So in order to assist the reader, we give one more drawing which helps the reader to understand the overall geometry of the object. Now let us understand about these isometric projections in detail. Over here we have orthographic projections. In the orthographic projection, we have only two dimensions. So these are 2D drawings. In the front view, we have length dimension and we have height dimension. In the top view, we have length dimension and width dimension. And in the side view, we have width dimension and height dimension. So we can say that for a particular projection or for a particular view of an object, we have two dimensions only. And in order to draw these three orthographic projections, we need three planes. For front view, we need vertical plane. For top view, we need horizontal plane. And for side views, we need profile plane. But now look at this isometric projection. In this case, all the three dimensions of the object are visible only in one drawing. You can see in this drawing, we can see its width dimension, we can see its length dimension, and we can also see its height dimension. So in just one drawing, all the three dimensions of the object are visible. And in order to draw this projection, we need only one reference plane, that is vertical plane. For that reason, we call these drawings as one plane drawings also. Now let us summarize what we have learned in the previous slide. We have learned that the detailed description of any object can be represented by orthographic projections. The orthographic projections can be correctly interpreted and quickly visualized only by those persons who have a good knowledge of principles used for these projections. Also, their execution requires a definite exercise of constructive imagination. Yes, of course. To make drawing more understandable, several forms of one-plane drawings are used to supplement the orthographic projections. These one-plane drawings can be easily understood by persons without any formal technical training and are also known as pictorial drawings. But these drawings are only auxiliaries to the standard method of orthographic projections. That means if we have to convey the design to the manufacturer, the primary drawings are orthographic projections. So these isometric drawings are acting as auxiliaries to the orthographic projections. Pictorial drawings are projected on a single plane of projection by the methods of axonometric projection, oblique projection, and perspective projection. So we have three methods which we can use in order to draw one plane drawings on a single plane. And in this lecture we are discussing about isometric projections, and isometric projection is a particular case of axonometric projection. So if we have to define isometric projection, we will say the isometric projection of an object is a single orthographic projection drawn with the object so oriented with respect to the plane of projection that all the three axes of the object are equally inclined to it. Now this is a very important definition. We will understand it through an example. The principle involved in isometric projection can be explained by considering the case of a cube. So we will understand this definition and the principle of isometric projection through the example of a cube. So let us understand that now. So let us understand the fundamentals of isometric projections. So for that we are considering the example of a cube. This is vertical plane, this is horizontal plane, and the cube is resting on the horizontal plane, and its position is such that its one face is parallel to vertical plane. So when we look at cube from front, we will see front view as a square. Now in the next step what we will do, we will rotate this cube so that its two sides should be at 45 degrees to the vertical plane. So let us see that position. So in the next position what we have done, we have rotated the cube. So you can see earlier this face was kept parallel to vertical plane. Now we have rotated the cube and the front two faces are visible to us, and these two are at 45 degrees to the vertical plane. So if we will look at cube in this particular position from front, then we will see two faces. You can see over here. Earlier, when the face of the cube was parallel to VP, we were able to see only one face, that was a square. But now in the second position, we have rotated the cube at 45 degrees, and you can see now we are able to see two front faces of the cube, and these two are inclined at 45 degrees to the vertical plane. So that's why we see these two faces as reduced faces. Now what we will do in the next step, we will tilt the base of the cube by some angle. You can see over here we have kept the front bottom corner of the cube on HP, and we have lifted its base by some angle. That angle is 35 degrees 16 minutes. You can see over here the front bottom corner is on horizontal plane, but base of the cube is lifted by 35 degree 16 minutes. So when we will look at the cube at this position from front, then we will see this face. You can see over here we will see this projection from the front. So in this projection we will see three principal faces of the cube, and this is called as isometric projection of the cube. And in this projection all the three dimensions are visible: length, width, and height of the cube. Now we'll discuss this position in the next part of this lecture in order to understand the fundamentals of isometric projection. So we have seen that in order to get the isometric projection of a cube, we tilt the base of the cube by 35 degree 16 minutes. So this is the front view of the cube in that position, or we can say this is the isometric projection of the cube. So when we will look at this cube from side, then its side view will show us its angle of inclination with the horizontal. So its base is inclined at 35 degree 16 minutes. And you can see over here, when we look at this isometric projection from front, this edge of the cube looks like that this is a vertical edge and it is parallel to VP, but it's not like that. You can see over here, this edge in the side view is visible over here. So this edge is not vertical, it is inclined to VP. In fact, these three edges of the cube are equally inclined to VP, and these edges are inclined at 35 degrees 16 minutes to the vertical plane. So now let us go back to the definition part again. See what he is saying. The isometric projection of an object is a single orthographic projection. Yes, this is a single orthographic projection. What next? Drawn with the object so oriented. So how we have oriented the object? So first of all, we have rotated the cube in such a manner that its side faces are inclined at 45 degrees to the plane of projection, that is vertical plane. Then we lifted its base by 35 degrees 16 minutes. So what next? So oriented with respect to the plane of projection that all the three axes of the object are equally inclined to it. Yes, of course. So when we will do this, what we will get, all the three axes of the cube are equally inclined to the plane of projection. So the projection so obtained is called as isometric projection of cube. So I hope now the definition of isometric projection is clear to you. Now let us move to the next part of this lecture. Now we'll understand few fundamentals of isometric projections. So for that, let us take the example of isometric projection of cube only. So over here we have isometric projection of cube drawn on the vertical plane. Now let us understand few important points about this isometric projection. Now in this case, you will find that the longer diagonals of these three faces are equal, or we can say the shorter diagonals of these three faces are equal, or we can say these three faces are identical. Now focus on this term, isometric. It consists of two words. Iso means same, similar. Metric means measurements. So those projections where measurements are same. So we have learned that when we will draw isometric projection of a cube, then in that case, these front faces, three principal faces of the cube are identical. And in this case, the front three edges of the cube are termed as isometric axes. And these axes are equally inclined to plane of projection. In this case, plane of projection is VP, and these three axes are inclined to VP at an angle of 35 degree 16 minutes. And another important observation we have to make over here is that suppose the size of the cube is 50 millimeters. But when we will draw its isometric projection, then its edges will be inclined to the vertical plane. So when you will look at cube in that particular position, then these edges will seems to be the reduced edges. Why? Because these are inclined to VP. So you cannot see their true length from front. Now in this case, there will be some reduction in the size of these edges. And in isometric projections, the reduction is 18%. That means when we draw isometric projection of any object, then in that projection, the size of the edges of the object reduces by 18%. So we see only 82% of the actual size of the edge. If the actual length of this cube is 50 millimeters, then we will see only 82% of that value. So in isometric projections, we see only 82% of the original length. And these lengths so obtained are called as isometric lengths, and these are 82% of the actual size. Now over here we have to understand one more important point. When we draw isometric projection of the cube, then in that projection, the angle between these front edges of the cube is 120 degrees. So the angle between any of these two edges of the cube in the projection is 120 degrees. And from here we have to understand one more important point, that if we sketch a horizontal line from this intersection, then we will get that angle of these two edges or these two isometric axes with the horizontal is 30 degrees. So whenever we have to draw isometric axes on a paper, what we need to do, we have to first draw a horizontal line and we'll mark a point on that line. Then from that point we will sketch two lines at 30 degrees. Those will be called as two isometric axes. And in order to draw the third isometric axis, from that intersection we have to draw a vertical line. So in that manner we can draw isometric axis on the paper. So we'll be able to satisfy this condition also, that between any two axes angle is 120 degrees. Next we will learn about isometric planes. Now these three principal faces of the cube, which are perpendicular to each other and are equally inclined to vertical plane, are called as isometric planes. And apart from these three principal faces, if we have any other face in the object parallel to any of these three principal planes, then that will also be called as isometric plane. Now you can see the principal faces are top face, right front face, left front face. Now if we will talk about the bottom face is parallel to the top face. So it means bottom face is also a isometric plane. The next is isometric lines. We have learned that front three edges of the cube are known as isometric axes. So any edge or any line present in the object parallel to any of these three isometric axes is called as isometric line. Now look over here. This edge or this line is parallel to this isometric axis. So this will be isometric line. Similarly, this edge or this line is parallel to this isometric axis. So this is also isometric line. Similarly, this line is parallel to this edge. So this is also isometric line. So any line or edge in the object which is parallel to any of these three isometric axes will be termed as isometric line. Next is non-isometric planes. So we will get some objects in which we will find that there are some planes which are not parallel to these three principal faces. We will call those planes as non-isometric planes. Similarly, we will get non-isometric lines. Means we will get edges in the object which will not be parallel to any of these three axes. So we will call those as non-isometric lines. One example can be if I draw one diagonal line over here, that diagonal will not be parallel to any of these three axes. So we'll call that as non-isometric line. So let us summarize what we have learned in the previous slide. We have learned that isometric means equal measure. As the name suggests, in isometric projection, all the mutually perpendicular plane surfaces of an object and the edges formed by these surfaces are equally inclined to plane of projection. Of course, these edges which are perpendicular to each other, or these planes which are mutually perpendicular to each other, these are equally inclined to plane of projection, and that angle in case of cube is 35 degrees 16 minutes. In isometric projection, only one view on a plane is drawn to represent the three dimensions of an object. This provides a pictorial view with a real appearance. So now we are very much clear what are isometric projections, and we have learned about various fundamentals also related to isometric projections. Now in the next slide we will cover few important definitions. So let us first discuss about isometric axis. So what is isometric axis? When we draw three lines over here, these are named as GH, GF and GC, meeting at a common point G and making 120-degree angle with each other are termed as isometric axis. Or how we can draw these isometric axes? We will first draw a horizontal line. On that line we will mark a point and we will use a protector. We will put protector at that point and we will draw two lines at 30 degrees on both sides. So those two will be called as first two isometric axes. Then from the third point we will draw a vertical line, that will be the third isometric axis. So in this manner we will get angle between any of the two isometric axes as 120 degrees. Now we have to understand one more important point over here. When we have to draw isometric projections of an object, we have to first draw isometric axes on the paper. So normally what we do, we draw a horizontal line. We draw two lines at 30 degrees to that horizontal line from a particular point on the horizontal line, and from that point we sketch third line in vertical direction. We draw that line either in downward direction or in upward direction. It is your choice. Both ways it is correct. And after this, if we have to draw isometric projection of an object, then on this axis we either assume length or width of the object. Similarly, on this axis we can assume length or width of the object. That means if we have considered length along this axis, then we have to consider width along this axis or vice versa. And this vertical axis we use for height of the object. And shortly we will learn about the procedure for drawing isometric projection of an object through these axes. Now we will discuss isometric scale. So let us understand what is isometric scale. Now this is the isometric projection of the cube, and this is the top view of the cube. And let us say the size of the cube is 50 millimeters. So this length is of 50 millimeters. In the isometric projection, we know these two edges of the cube are inclined at 30 degrees to the horizontal line. So if I sketch a horizontal line over here, then we can say this line is also at 30 degrees to this horizontal line. But if we will observe the top view of the cube, in the top view, this angle is 90 degree because it is a square, and half of that will be 45 degrees. But you can see in the isometric projection, the top face of the cube is here, and this angle is 30 degree in the isometric projection, but actual angle is 45 degrees. So let me represent this face over here in order to understand the fundamentals better. So we have represented this face over here. Now you can see this is the true length or true edge of the cube, which is of 50 millimeters. But in the previous slides we have learned that when we look at isometric projection, in isometric projection edges are of 82% of the actual length. Means these are reduced lengths, and we call these as isometric length, but this is true length. So we can say that this length is 82% of this actual length. And this forms the basis of isometric scale. And let us understand this through mathematics also, that this edge in the isometric projection is 82% of the actual size of the cube. So for that, let us draw one vertical line over here and let us mark these points as O, A, B and C. Now we will consider two triangles over here, OAC and OBC. Now, the definition of isometric scale is that isometric scale is equal to isometric length divided by true length. OB is isometric length and OA is true length. So let us see what is the size of OB, that is isometric length. So for that we have to consider this triangle OBC. In this triangle we will say base upon hypotenuse is equal to cos 30 degrees, or hypotenuse will be equal to base divided by cos 30 degrees. So isometric length, that is OB, will be equal to OC divided by cos 30 degrees. Now let us find true length. For that we will consider this triangle OAC. In this triangle we will say base OC upon hypotenuse OA is equal to cos 45 degrees. And we will get true length OA is equal to base OC divided by cos 45 degrees. So when we'll put these values over here, we will get OC divided by cos 30 divided by OC divided by cos 45. So this will be equal to cos 45 divided by cos 30, and from here we will get 82%. So we have learned that isometric lengths are 82% of the actual length or the true length. Now the purpose of isometric scale is that whenever we have to draw isometric projection of any object, so we will be given object which will have true lengths. So first of all we have to convert those true lengths to isometric lengths. Means we have to convert true lengths by reducing their size to 18%, or we have to consider 82% of the actual lengths. So whatever original dimensions will be there in that object, we have to first reduce those dimensions to 82%, and only then we can use those dimensions for isometric projection of the object. So in that case, isometric helps us to find isometric lengths. Now we'll learn how we can obtain isometric scale on paper. So we will use the same procedure which we have learned in the previous slide. So first of all, we will draw a baseline. Let us call it as OC. Then we will put protector at this end and we will sketch a line at 30 degrees and we'll call it as OB. So this is isometric length. And then again we will put protector at this point and we will draw another line, but this time at an angle of 45 degrees. So let us call this as OA. So this is true length. After this, what we will do? On this length, we will draw actual scale. And we'll call this as true length. Then from the points of actual scale marked on OA, we will take vertical lines in downward direction so that these should intersect OB. Then we will use these intersections to draw second scale on this length OB. So this scale or this length will be called as isometric length. Now you can see actual 5 centimeters have this length, but corresponding to that true 5 centimeters we have isometric length over here, which is 82% of the actual length. So in this manner we can construct isometric scale on paper. Now we will learn about another important topic, that is isometric view or isometric drawing. So these two terms are same, isometric view, isometric drawing. So let us understand what are isometric views or isometric drawings. Isometric projections is often constructed using isometric scale, which gives dimensions smaller than the true dimensions. Of course, if we have a cube of, let us say, 40 mm and we want to draw isometric projection of that cube, we first have to reduce 40 mm to 82%. Only then we can sketch the isometric projection of the cube. Similarly, if we have some other object, first of all we have to reduce all the original dimensions of that object by 18% or up to 82%. Then we will use those reduced dimensions to draw isometric projection of the object. However, to obtain isometric lengths from isometric scale is a cumbersome task. Of course, now let us assume that we have an object in which, let us say, 20 dimensions are there. So we have to reduce those actual dimensions first to isometric lengths by using isometric scale. That means we have to do reduction for 20 times. So that is quite difficult task. So more the number of dimensions in an object, then this task will become more difficult. Therefore, the standard practice is to keep all dimensions as it is. So in order to get rid of this cumbersome task of getting isometric lengths for actual lengths through isometric scale, what we do, we don't reduce the actual dimensions of the object. We use actual dimensions as it is, but we follow all the fundamentals which we have learned under isometric projections. So in that case, the view thus obtained is called as isometric view or isometric drawing. So what we have done? We have followed all the fundamentals of isometric projections, but while drawing those projections, we are not reducing actual dimensions to isometric lengths to get rid of this cumbersome task. So we have drawn isometric projections by following all the fundamentals, but we have used actual dimensions while drawing those projections. So whatever views we will get with that method, those views will be called as isometric views or isometric drawing of the object. So let us understand that through an example. Over here we have orthographic projections of a cube. So this is the front view, which is a square, and this is a top view, which is again a square, and the size of the cube is 40 millimeters. Now if I have to sketch isometric projection of this cube, then first of all I have to reduce the size to 82%, and that will be 32.8. So I will sketch isometric projection, but in that projection I will take the length of each edge as 32.8 mm. But if I have to draw isometric view of this cube, then I will follow all the fundamentals of isometric projections, but in drawing, while drawing these edges, we will not reduce their length, we will use actual length. So that view will be called as isometric view or isometric drawing of the cube. And you can see isometric views are slightly larger than isometric projections because we are using actual dimensions. So as the isometric view utilizes actual dimensions, the isometric view of the object is seen larger than its isometric projection. Now in the next slides, we will learn isometric views of some standard shapes. So first of all, we will learn about isometric view of a square. So we have a square over here, and we want to learn how to draw its isometric view. Isometric view of a square is a rhombus. Now let us understand how to draw isometric view of a square. But for that, let us first draw isometric projection of a cube, because cube has square faces and it will help us to understand isometric view of this square. Now we know in case of a cube we have square faces. And in isometric view of a cube, we have three principal faces visible to us. And this is the isometric view of the front right face of the cube. So we'll call this as right side isometric view. Now this is isometric view of left front face of the cube, which is a square. So we'll call this as left side isometric view. And this is isometric view of the top face of the cube, which is also a square. And we'll call this as top isometric view. And you can see in these three cases, the isometric view of the square face is a rhombus. So first of all, we will learn how to draw isometric view of this face, means right side isometric view. So let us name this face as A, B, C, D. So A, B, C, D. So let us draw its right isometric view. That means this view. So how we can draw this view? First of all, we will draw a horizontal line. On that line, we will mark a point. Let us consider that point as this point, point A. And let us mark that point as point A. Now in the right isometric view, you can see it has length and it has height. So we will draw two axes over here. One axis which is representing length and other axis which is representing height. Third isometric axis representing width is not required over here because right now we are talking about only a plane. So at this point we will put our protector and we will draw first isometric axis at an angle of 30 degrees to the horizontal. So on this axis we will represent the length and we will draw this length to the size of the square, which is 30 millimeters. So this length is of 30 millimeters. And we will mark this point as point B. After that we will sketch these two vertical lines. It means from this point and from that point we will sketch two vertical lines and the length of those lines will be equal to 30 millimeters only because it is a square of 30. So we have drawn a line of 30 millimeters from point A. It is a vertical line or the second isometric axis, which is vertical axis, and this point will be labeled as D. Similarly, from point B, we will draw a vertical line of 30 millimeters, and this point will be called as C, and we will connect these two points to get isometric of the square. And this is which isometric? It is right side isometric of the square, which is a rhombus. Now we'll learn about left side isometric view. So let us see how we can draw that. So let us consider this left side isometric view now. So let us label these points as A, B, C, D. So this is A, B, C, D. So first step is draw a horizontal line, mark a point and consider that point as this left corner of the square. Label it as A. Now we need to draw left isometric view. It means now we have to use left isometric axis. So on that axis we will draw the length of the face, which is 30. So we'll put our protector at this point and we will draw a line at 30 degrees and length of that line will be 30 mm and this is the first isometric axis. And this edge will be edge D. Then from this point we will draw the second isometric axis, which is vertical, and we will keep length of that isometric axis as 30 millimeters. And we'll call that point as B because on the right side of A we have B, on the left of A we have D. So on the left of A we have drawn D, then on this side we have to draw B. Similarly, from point D we have to sketch a vertical line of 30, then we will call that point as C. Then we will connect these two points to get the left isometric view of square, which is again a rhombus. Now we'll learn about top isometric view of a square. So let us label it as A, B, C, D. So this is A, B, C, D. So first of all, we'll draw a horizontal line. We'll pick again the same point and mark that point on this line, call that as A. Now in top isometric view, you can see we have two dimensions. One is length, other is width. There is no height dimension. It means in case of top isometric view, we never draw the third isometric axis, which is the vertical axis. So what we will do, we will put our protector at this point and we will draw two lines of 30 each at an angle of 30 degrees to this horizontal line. So those will be called as two isometric axes. So on the left of A we have point D, on the right of A we have point B. So we have marked on the right of A as B, on the left of A as D. Now after this we have to draw these two edges. So how we can draw these two edges? In front of this edge or this isometric axis, we need another line at this place which should be of same length and parallel to this axis. Similarly, in front of this axis or this edge, we need another line at this place which should be of same length and parallel to this axis. So for that, what we will do? We will measure this distance with the help of compass. And we know this distance is 30. So we will open compass to 30 millimeters and we will place compass at this point and we will draw an arc. Then in front of this length we need same length. So we'll open compass to this length which is again 30, but this time we will put compass at D and we'll draw another arc which will intersect the first arc drawn by us. So that point will be point C. And we'll connect these 2 points to get the top isometric view of square, which is again a rhombus. Now next is isometric view of a rectangle. So the isometric view of a rectangle will be a parallelogram. And in order to construct isometric view of a rectangle, we will use the same fundamentals which we have learned about isometric view of a square. With those fundamentals, you can draw right isometric view of a rectangle, left isometric view, and top isometric view of rectangle. Next, we have isometric view of a triangle. Now, in this case, we have to follow a different method. We call that method as a box method. So remember, if the plane is not a square or rectangle, then in that case, we have to first draw that plane on paper. And we have to enclose that plane inside a box. Then first of all we will draw isometric of that box. Then in that box we will generate isometric of that plane. So in this case we are given one triangle and first of all we will draw this triangle on our paper with the given dimensions, and after that we will enclose that triangle inside a rectangle. So how we can enclose this inside a rectangle or a box? From these 2 points we will sketch two vertical lines, thin lines, and from this point we will sketch a horizontal thin line. So in this manner we will enclose the given plane inside a rectangle or inside a box. First of all we will draw isometric view of the rectangle, and that we have already learned in the previous slides. So let us name that rectangle as A, B, C, D, and let us name this triangular plane as AB1. So first of all we will draw isometric view of this rectangle ABCD, and let us draw its top isometric view. So in top isometric view we use two axes, one axis towards right, one axis towards left, both are at 30 degrees to the horizontal, and we don't use vertical axis in top isometric view. So first step is we will draw a horizontal line. On that line we will mark a point, and let us consider this lower left corner of this rectangle and let us call this point A. Then we will put protector at this point and we will sketch the length of the rectangle on right side, on the right axis, and it is of 40 millimeters. So we will draw a line at 30 degrees and length of that line will be 40 millimeters, and we will keep this line thin, because this is not the final answer, it is the isometric of this rectangle only. Now we will call that point as point B. Now after this, what we will do, we will again put protector at this point and we will draw the second isometric axis which will represent width of that rectangle. So put your protector at this point and draw second isometric axis of any length at the start, and that will be at 30 degrees to the horizontal. Then we have to measure the width of this rectangle. So for that, what we need to do, we use compass. Put compass at A, open compass to AD. After measuring this width AD, put your compass back at A and cut this length to AD, and we will erase the remaining length or remaining isometric axis. So we have drawn length AD on this isometric axis. Then in order to complete isometric view of this rectangle, we need a length in front of this isometric axis over here, which will be of same length and parallel to AD. Similarly, in front of this length, we need another length over here of same size and parallel to this length AB. So for that, what we will do, we will use compass. We will open compass to this length, which is 40 millimeters, and we will place compass at point D and we will sketch an arc. Then we will measure AD with the help of compass, and after measuring AD, we will place compass at B and we will draw another arc which will intersect the first arc drawn by us. So that point will be point C. And we'll connect these points to get isometric view of the rectangle. So first of all, we will draw isometric view of the rectangle. In that view, we will draw isometric view of the plane, which is triangle in this case. Now for drawing triangle in this isometric projection, we have to represent three edges, A, B, B1 and 1A. You can see AB is on this edge of the triangle, which is AB. So it is a common edge between triangle and rectangle. So we will make this edge thick. Now this edge is representing edge of triangle. Now we have to locate point 1, which is in between C and D. So for that, what we'll do, we will put compass at point D and we'll open compass to this distance D1. We'll measure this distance D1 from here and we will place compass at D and we'll cut that distance on this length. So this point will be point 1. Then we will connect B1 and A1. So we will get isometric view of triangle. Remember, don't measure B1 because that will give wrong results. Always measure from the corners of the rectangle drawn by us. So we have measured from D1 and we have marked from D. Only then we will get correct isometric of the given planes. So we have learned that if we don't have square or a rectangle for which we have to draw isometric view, then first step is draw that plane first with actual dimensions, enclose that plane inside rectangle or box, draw isometric of that box first. In that isometric, you can create isometric view of the plane given to you. So with the similar steps, we can draw isometric view of any other shape like pentagon, hexagon, octagon. Same steps we have to follow for other planes. Now we'll discuss isometric view of a circle. Now isometric view of a circle is an ellipse. So let us see how we can draw that ellipse. So for that we need one method. That method is called as 4-center method. So now we will understand 4-center method, which is used to draw isometric view of a circle, which is an ellipse. So let us say this circle is of 50 millimeters. And when we will enclose this circle inside a box, we will always get a square. So first of all, we will draw isometric of this square of 50, that will be a rhombus. So we'll draw a horizontal line and we'll sketch isometric of that square, which will be a rhombus, by same steps which we have learned in the previous slides. And now we are drawing top isometric view of circle. So we have chosen length and width. Height is not considered. Now let us see what we do in 4 center method. In the next step, we mark the midpoints of these sides. So if this is 50, midpoint will be at 25. Similarly for these sides, midpoint will be at 25. So let us mark these midpoints and let us name these midpoints as A, B, C, D. After that, we will consider two corners of this rhombus and we will consider corners of shorter diagonal. So this is the shorter diagonal. So we'll consider these two corners and we will call these two corners as center number 1 and center number 2. The name of the method is 4 center. So we have created two centers and with the help of these two centers we will create two more centers. So we will get 4 centers and those 4 centers will help us to draw 4 arcs which will form an ellipse. So we have considered the corners of shorter diagonal. So this is center 1, this is center 2. Then in the next step, we will draw a line from first center to the midpoints of opposite sides. So for this center, midpoints of opposite sides are A and B. So let us draw continuous thin lines to those two midpoints. Same step we will follow from the second center, means draw continuous thin lines to the midpoint of opposite sides. So for this center, midpoints will be C and D. So in this manner, we will generate two more centers. So these intersections are called as center number 3, center number 4. So let us label these centers. This is center 1, center 2, center 3, center 4. Now we will use compass. We will put compass at center number 1 and we will open compass to this distance 1A and we will draw an arc between A, B. Then we will put compass at center 2 and we will open compass to 2C, which will be equal to 1A only, and we will draw an arc between C, D. Then after that we will make use of these two centers. So let us put compass at this center and open compass to 4B. You can also open to 4C because 4B is equal to 4C. So put compass at 4, open compass equal to any of these two distances. So let us open to 4B and connect these two arcs with another arc. Then put your compass at center 3 and open compass to any of these two distances, either 3A or 3D, and draw another arc. So in this manner we will get an ellipse that will be called as top isometric view of circle. So this method is called as 4 center method. Now if we have to draw the right isometric view, so what we will do? We will draw right isometric view of the square, which will be a rhombus. So we have taken right axis, right isometric axis, we have drawn this 250. Then from these 2 points we have drawn 2 vertical lines of 50. Then at the top we have connected these 2 points. This we have already learned in the previous slides, how to draw right isometric view of a square. Then we'll mark the midpoints of these sides and we'll label these midpoints as A, B, C, D. Then we'll consider first two centers. Those will be the corners of the shorter diagonal. So this is the shorter diagonal. So this center and this center will be the first two centers. So let us mark these two centers. Then from the first center we will draw continuous thin lines to the midpoint of opposite sides. Then from the second center draw continuous thin lines to the midpoint of opposite sides. In this manner we will generate two more centers. So these intersections are center number 3, center number 4. So let us mark these centers, center 1, 2, 3, 4. Then we will use first center and 1B as radius. We will draw an arc between AB. Then we will use second center 2D as radius and we will draw arc between DC. Then we will use Center number 3 and radius equal to 3a, we will draw the third arc. Then we will use center number 4 and radius equal to 4b, we will draw fourth arc. So in this way we will get right side isometric view of a circle which is an ellipse. So we have learned the fundamentals of isometric projections and we have seen isometric views of standard shapes also. In the next lecture we will learn about isometric view of a cone. Thank you very much.